Hello, mathematicians. Welcome to session 1, exploring fractions as tenths and hundredths. So lesson 25 for this week, you're using fractions still, but we're going to really look at the tenths and the hundredths and the relationship between tenths and hundredths. And for you decimal fans, you're going to love this because you can totally do it decimal style, and that will work. So that's our learning target, expressing a fraction with the denominator as 10, making it equivalent to hundredths. So it's like dimes and pennies. Super fun. Here we go. Draw a model to show 4 tenths, then draw a model to show a fraction equivalent to 4 tenths. So I'm going to go with an area model. So I'll make 2 equal size rectangles. To show tenths, I need 9 cuts. 1, 2, 3, 4, 5, 6, 7, 8. Well, I don't like that one, so I am going to restart. Yours probably looks a lot better. Maybe I'll make some bigger boxes, and maybe that will help me. 2 bigger ones to do ninths. 1 or tenths. 2, 3, 4, 5, 6, 7, 8. Much better. And that's going to be my 4 tenths. I'm going to switch to a color and shade in 4 of them. 1, 2, 3, 4. Okay, so this is a picture of 4 tenths. Now I need to make something equivalent. Draw a model that is equivalent to 4 tenths. So what I am going to do is start at the beginning with my 4 tenths, and let me do 9 cuts again. 1, 2, 3, 4, 5, 6, 7. All right, not exactly equal pieces, but you get the idea. And then I'm just going to, do a times 2 times 2. So I'm going to just do a cut right there. So now I've got double. So times 2. So I have twice as many, and times 2. Okay, because times 2 over 2 is 1. That gives me 8 20ths. And I should have the same shaded in. So I switch to, I want to do green so we can see it better. 1, 2. Okay, so there's my 4 tenths, but that is equivalent to 8 20ths. If you count them, there's 1, 2, 3, 4, 5, 6, 7, and 8. 8 20ths is equivalent to 4 tenths. All right, I'm sure you're ahead of me on that one. Make sense of the problem. Das rides his bike home. He has 7 tenths of a mile left to ride. Write an equivalent fraction to show how far Das has left to ride in hundredths of a mile. So what's the problem about? Das riding his bike. Okay, he's riding his bike. It's a bike question, and it's about tenths and hundredths. Okay, next one is, what are you trying to find out? Das rides his bike home. He has 7 tenths of a mile left to ride. Write an equivalent fraction to show how far Das has left to ride in hundredths of a mile. So what are we trying to find out? An equivalent fraction. We are trying to find an equivalent fraction. Okay, so we are going to have this fraction equals another fraction. Equivalent fraction. Last read is, what information is important? Let me switch colors. Das rides his bike home. He has 7 tenths of a mile left to ride. So 7 tenths left to ride. That seems important. We need an equivalent fraction to show how far Das has left to ride in hundredths. Okay, so there you go. On the next slide on page 519, it's missing. We're supposed to solve it. So I'm just going to go ahead and solve that on this one, and you can be ahead of me if you like. So we are trying to take 7 tenths and then find an equivalent fraction. So you could draw a picture like we did at the first problem, draw 7 tenths. But we need to change it to hundredths. And drawing 100 things a little bit exhausting. So I think, and I don't have the fraction. If I had base 10 blocks, you know, switching from tenths, like the longs, 7 longs, that would be easier to switch because then you could see it in it. I'm going to use the multiplying strategy, but I'm going to be thinking about the blocks. So if I need to change this, to hundredths, because that's the goal right here. What is it in hundredths? I want it to be hundredths. To get to hundredths, I do 10 times 10. So if I'm multiplying 10 here, it's like taking the 10 rods and breaking them up into 10 pieces, into the little pieces. So if I do times 10 here, I must do times 10 here, because equivalent means equal. So if I multiply by 1, it will stay equal. 7 times 10 is 70. So that's my answer. It's like saying 7 dimes, 70 cents, is the same as 70 cents, 70 pennies, right? 7 dimes equals 70 cents. Okay, there we go. That's next one. Oh, we just did that. Here we go. Ask your partner, why did you choose that strategy? Tell your partner and you what you knew. Okay, I chose the strategy of multiplying the denominator times 10 and the numerator times 10. I chose that strategy because it was easier than drawing out all the 100 pieces. And I knew that 100, or it was just easier to just see the numbers there. I also know it works from the base 10 blocks. So thank you. Just got some more mail. Super cool. I am super lucky. All right. Explain how you could use multiplication on page 520 to find a fraction with a denominator of 100 that is equivalent to 7/10. Okay. How can you use multiplication? Just a second. Oh, sorry. So we got 7/10. So that's the way I did it, was with multiplication. How can you use multiplication to find a fraction with a denominator of 100? You ask yourself, if you want to change this denominator to hundreds, you ask yourself 10 times what equals 100. So if you take that 10, how many parts do you have to cut the 10 into? 10. Because if you make it into a 10 by 10, you'll have 100. Okay? So that's how you do that. Next one. Every fraction with a denominator of 10 can be written as a fraction with a denominator of 100. It's like saying you have 7 dimes. You can change them to 70 pennies, and it still equals. 70 pennies equals 7 dimes. The model at the right is divided into 10 equal parts, or tenths. How many parts are shaded? Well, we have 3 not shaded, so that's going to be 7. So that's like showing the 7 rods, what I was talking about at the beginning. Then right here, it's like changing it to the little tiny base cubes. If you split each 10 equal parts, the whole is now divided into 100 equal parts, or hundredths. How many hundredths? So like this right here represents one whole dollar, 70 cents on a dollar. This is $1, but now we have pennies. How many are shaded? 70. Complete the equation to show a fraction with a denominator 100 that is equivalent to 7/10. Okay, same work we were doing earlier, changing it. It's just showing the parts. So whatever you multiply the denominator by, you have to multiply the numerator by. So this is going to be times 10 because that equals 100. So this one is times 10. All right, it's basically showing here picture way, equivalent fraction way, and down here is the money way, my personal favorite. You can also use money to think about equivalent fractions with denominators of 10 and 100. Think of $1 or 100 cents as the whole, fill in the blanks. So 1 dime equals 10 cents, which is 10 pennies out of $1. 1 dime is 1/10 of $1. So 1/10 of $1, which is a dime, equals 10 pennies. Okay, that's just saying 1 dime equals 10 pennies. Okay, tenths and hundredths, pretty cool to think of when you think of it like money. How can you use equivalent fractions to write tenths as hundredths? Okay, so this is just reflection. So the equivalent fraction strategy is, let's say you had 3 tenths, because it's saying how can you use equivalent fractions to write tenths as hundredths. Okay, so that strategy is just saying you're going to change it. How do you change a tenth to 100? You basically are taking those tenths and you're cutting them up into 10 little pieces, each one. Take the rods, cut it up into 10. Take the dime, cut it into pennies. You know what I mean? So to make it equivalent, you have to multiply by 1, multiply by 1, multiply by 1. So this has to be times 10. Okay? 10 times 10 is 100. 3 times 10 is 30. So 3 tenths equals 30 hundredths. All right, that's the big learning for this lesson. On page 521, you get to put in your own words what is a numerator. So get all these words down. You might need to push pause if I go too fast. Denominator, tenths, and hundredths. Okay, and then an example. Okay, so an example of tenths, you can write that as a fraction. You can write it as a decimal. You can write it as like that. Those are all equivalent. You can also put like a tenth is a dime. Okay, hundredths is your pennies. So that's hundredths. And if you're going to use base 10 blocks, you could draw a picture here. That could be 1 rod. If this is 1 whole, the flat. If the flat is $1, then the rod is a tenth, and a little tiny cube, little baby cube, is a penny. Okay, if you use the big cube as a whole, it's a whole different game. So be careful of that. So tenths are the whole split into 10 parts. Okay, the whole divided by in 10 parts. I don't have, it's hard for me to write in there. Maybe I should type this one in. And hundredths are the whole divided, what's the option? Or the whole divided by 100. That is a hundredths. Take the whole thing and put it into 100 parts. Numerator is how many you have. Denominator is the size of the fraction. Okay. And that's the bottom number is the denominator. Numerator is the top number. Okay. So for example, if you've got 35 hundredths, that's the numerator. You have 35 pennies out of 100 pennies. The denominator down here is this bottom number. So if you had 25 hundredths, that's the denominator, and it's the size. So the size for this example is hundredths, or pennies if you're using money. All right, so you get to finish pages 521 and 522 on your own. All right, mathematician, see you next time. Bye.